Hello everyone, welcome back to this YouTube channel IBwontcrushyou, and today we're dealing with trigonometric functions, and so let's get started. Problem 1a. On the unit circle, what are the coordinates of the point corresponding to the angle theta equals 0? So firstly, we have to remember what a unit circle is. So a unit circle is basically a circle with a radius of exactly 1, and it's centered at the origin, so the origin has coordinates 0 and 0 of the Cartesian coordinate system. And the first coordinate in the unit circle is cosinus theta, and the second coordinate is sinus theta. So all we need to do is to substitute our angle, so theta 0, into these coordinates. So cosinus 0 and sinus 0. You can check it on your GDC, or maybe you remember that the cosinus 0 is just 1 and sinus 0 is just 0. B. What are the coordinates of the point corresponding to theta equals pi over 2? So the same. We have to substitute into angle pi over 2. So cosinus pi over 2 sinus pi over 2. And you can check it on your GDC, or maybe you remember that. And this is 0 and 1. And point C, from these results state the values of sinus 0, cosinus 0, sinus pi over 2, cosinus pi over 2. So all we need to do is basically to rewrite our answers from the previous points. So sinus 0 is 0, cosinus 0 is 1, sinus pi over 2 is 1, and cosinus pi over 2 is 0. Problem 2. Consider the function y equals 2 cosinus and in bracket theta minus pi over 4 minus 1. A. State the amplitude, period, and vertical shift of the function. So, firstly, our amplitude. So we write A, and amplitude is always something in front of our function. So in our case, it's just 2. So amplitude equals to 2. Then we have to period. So period is basically 2 pi over b. So this is the formula that you have to keep in mind. So we can, from this formula, we can calculate period as well as b, because we can rearrange this equation and have formula for b from our trigonometric functions. However, here we have to calculate period. So 2 pi over b. And b is the digit that is in front of our angle, so in front of theta. And in front of theta, we have basically 1. So our period is 2 pi over 1, so it's 2 pi. And vertical shift. So vertical shift is the digit that is in here, so next to the bracket, so basically minus 1. And this is of course our horizontal shift. However, we're not asked to provide it, so we won't. And in B, sketch the graph of the function for theta from 0 to 2 pi. So all we need to do is just to type our trigonometric function into our GDC, and then we have to set the domain. So our cosine function looks like this, and here we have to stop our function because we are given domain from 0 to 2 pi, and see the graph intersects x-axis at 2 points in this interval. Use your GDC to find their approximate values in radians, 3 decimal places. So basically all we need to do is just on our GDC once again draw our function, then choose gsolve and then root. And in our domain, x is 1.83, and the second x, because we have two x-axes, is 6.02. Problem 3. A trigonometric function is defined by y equals a sinus and in bracket bx plus c and plus d. It has amplitude 3, period pi, a minimum value minus 2 at x 0. A. Determine the values of a, b, and d. So we can start from amplitude, which is basically a. So a is 3. However, amplitude is absolute value of a, so it can be also negative 3, but we'll check it later. So for now we can leave it as 3. Then b. So as you remember, period is 2 pi over b. So now we can rearrange it, or basically substitute pi as period, and it equals 2 pi over b, and maybe now we can rearrange it. So firstly times b, so pi b equals 2 pi, and we can divide both sides by pi, so it cancels out, so b equals 2. And we have to find d. However, d is kind of tricky to find because as you remember, d is vertical shift. So basically it is a middle line of our graph. So and because in here we have sinus function, so its range is from d minus absolute value of amplitude, so 3, and to d plus absolute value of amplitude. So we can write it down. So our d minus absolute value of our amplitude, so basically 3, to d plus amplitude. And we know that the minimum value is minus 2 at x 0. So this is our minimum value, this is our maximum value, so d minus 3 is minus 2, so we can move negative 3 from the left hand side to right hand side, and we have d equals 1. So d is 1, and in this case you have to remember that d is our vertical shift, and we cannot write that d is just minus 2 or something like this, because here we are given amplitude 3, period pi, so we can simply calculate from this formula for period. However, in here we have to be careful, because we are given a minimum value, so we have to remember that minimum value is d, so vertical shift minus amplitude, so we have to just substitute this value, and just calculate D. And in B, find one possible value of C. So maybe let's firstly rewrite our function with our values that we already found. So y equals 3 sinus b is 2x plus c and plus d, so plus 1. And now we have to find c, so our horizontal shift. And we know that we have one point that we can substitute. We know a minimum value minus 2 at x0. So minus 2 equals 3 sinus, and in a bracket 2 times 0 plus c plus 1. So from this we have minus 2 equals 3 sinus c plus 1. So now we can move 1 from the right hand side to left hand side. So we will have minus 1 minus 2, so minus 3 equals 3 sinus c. And now we can just divide both sides by 3. So minus 1 equals sinus c. And now we have to solve it. And we can do different ways of solving it. So we can graph it and then find it from the graph from GDC, or we can type it into solver. So I did it in solver, and my answer is minus pi over 2 and then 3 pi over 2 and so on. However, here we're asked to find one possible value of c, so it's enough to find this value. So in other words, in degrees it's minus 90 degrees. However, here we have it in radians, so minus pi over 2. And point C, write down a full equation for the function. So here we have to substitute these values only, and this is our full function. Problem 4. The temperature in a city during the day can be modeled by a cosine function. T equals a cosine, and in bracket b, and in bracket t minus c, and plus d, where t is the time in hours after midnight. Measurements show the minimum temperature 12 Celsius degrees occurs at 4 a.m. The maximum temperature of 28 Celsius degrees occurs at 4 p.m. A. Find the values of A, B, C, and D. So as always, we will start with amplitude, and here we have to use a small formula for amplitude. So amplitude is maximum value minus minimum value divided by 2. So amplitude is maximum temperature, so 28 minus minimum temperature, so 12, and divided by 2. So from this we have 8. Also we can use a small formula for D, because it's almost the same as for amplitude, however only the sign is different. So here we have maximum value plus minimum value divided by 2, so D equals 40 divided by 2, so it's 20. In order to find B, we have to use also our formula. The period is 2 pi over B, and here we know that the temperature in a city during the day can be modeled by. So our period is just 24 hours because we're calculating based on the whole day. So 24 hours equals 2 pi over b. So now we can rearrange it. So times b, so 24b equals 2 pi, and divide both sides by 24. So b equals 2 pi over 24. So basically b is pi over 12. And C is the horizontal shift, and it's kind of difficult, maybe not to find, but to know these all steps. Firstly, our cosine function reaches its maximum when our x argument equals 0. And in our function, argument is this. So b and in bracket t minus c. And we know that the maximum temperature is 28 Celsius degrees, and it happens at 4 p.m. So we have to also remember that 4 p.m. is like 16. So our b times in bracket t minus c equals 0. So this is the argument, and this is for t16 because it occurs at 4 p.m. So in other words, 16. So now we can substitute our values. We already found b, so pi over 12, and here t, so 16 minus c, and it equals 0. So now we can divide or maybe multiply both sides by 12 over pi. So 16 minus c equals 0. So 16 is c, so c equals 16. B, write down the full model for t. So we have to substitute our values. So our function is t equals, firstly a, so 8 cosinus, then we have b, so b is pi over 12, then in bracket we have t, so it stays without substituting, and then minus 16 and plus 20. C, use your model to estimate the temperature at 9 p.m. So also in here we have to remember that 9 p.m. Is like 21. So we have to substitute 21 into small t. So like this, 8 cosinus pi over 12, 21 minus 16 plus 20. And we have to calculate it, and you have to be careful because you have to have radians in your settings. So make sure that you have radians, and this is equal to 22.1 Celsius degrees. D, at what time or times is the temperature equal to 20? Give your answer to 2 decimal places. So we know that our temperature is equal to 20. So we can solve it in one of two ways. So either typing it into solver, or graphing it and then find a small t. And I used a graph function to find them. and the values of t are 10 and 22, so at 10 a.m. and 10 p.m. Problem 5. A sum wave is modeled as the sum of two trigonometric functions, f equals sinus and in bracket 2 pi t plus 0.5 sinus and in bracket 4 pi t, and t is greater or equal to 0 and it's our domain. A. State the period of each component function. We have to find period for this and for this because these are our two functions that are added. However, we have to find period of each function. So as you remember, period is 2 pi over b, and b is everything that stays in front of t, so basically 2 pi. So for the first function, this is 2 pi over 2 pi, so it's 1. And for the second function, this is also 2 pi over b, so 2 pi over, and here we have 4 pi, so this is 0.5. And in b, we have to use our GDC to sketch the graph of f for t from 0 to 2. So our function more or less looks like this, and c determine the maximum value of t in this interval, so probably you already know it because from graphing it on the paper, you needed maximum value to graph it correctly. So our maximum value, and here we have f, so maximum value f is 1.30, and we don't have to write at what t, so basically our answer f, we can write also max f maximum equals 1.30. And that was the last problem from this topic, trigonometric functions, from geometry and trigonometry chapter. And if you found this video helpful and useful, you can leave thumbs up, subscribe to my channel, and in case of any questions, feel free to reach me out in the comments down below or via my mail. That is, as always, in the description of this video. Bye!